this video, we're going to continue looking at ggplot. So to get started here, you'll notice I've got the module 5.2 script. And then the other thing you'll need to get off of Canvas is the data set, which is the student_mat.csv. And you'll want to have those both in whatever folder you're working on your computer. So just as a reminder, one way to navigate folders on your computer through RStudio is to click the three dots here. You can open up this navigator. Now this navigator is only going to navigate through folders, so you won't see individual files, but you'll navigate to the folder where you have the information, click OK, and then the contents of that folder will appear down here. Alright, so just a reminder, remember that ggplot2 is one of the core members of the tidyverse. The packages in the tidyverse share a common philosophy of data and R programming, and they're designed to work together naturally. So usually when we're using ggplot, I recommend just installing the tidyverse package and then calling that tidyverse package forward using the library command. You could just as easily call ggplot2 by itself and everything would work the same. Alright, so we're going to start out by looking at barplots and histograms. So the data we're looking at were obtained in a survey of students' math and Portuguese language courses in secondary school. It contains a lot of interesting information about social, gender, and study information about the students, and there's a link here if you want to read a little bit more about that data set. But the first thing we're going to do is read in the data set. So as a reminder, it's always a good idea to set your working directory. So I've got that line of code here. And then just as a reminder, another way that you could auto-populate that code into your console and copy and paste into your script would be if you have that folder with the files open over here, you can click on the More button and set as working directory, and notice it will produce that line of code for you, and then you can copy and paste that into your script for later use. So I'm going to use the read.csv function to read in that data set. Just kind of as a side note here, if your data set is in an Excel sheet, there are also ways to read in Excel documents that aren't CSVs. Those do require an extra package, but if that's something that you need to do for your research or your work and you want help with that, just let me know and I can walk you through that. Once you read in a data set, it's always a good idea just to kind of look at it, make sure it seems reasonable, everything read in. So I could come up here. You can see the student data has 395 observations of 33 variables. Clicking the down button and kind of get a look at some of those variables that are included. I could also look at the structure of student data. It will give me that same information. It will tell me it is a data frame. Again, 395 observations of 33 variables. And again, I can go through and look at all of those different variables. And then finally, if I just want to see the first six rows of the data set, we could do this here. Now notice this data set does have 33 variables, so that's why it breaks it onto different lines, because we don't have enough room horizontally to show all 33 variables. So just scrolling through here, again, I can look at the different variables and then the first six values for each of those variables. So the first thing we're going to do is look at histograms. We've looked at histograms in the past. Here we're going to look at how to clean them up just a little bit. So we're going to start out by creating a histogram of the age variable. And again, we've done something similar to this before. And here is the histogram it produces, and notice that we get this warning here that says you probably should pick a better value for bin width. So let's talk just a little bit about what's going on here. So by default, ggplot, what it's doing is it's constructing a histogram and it's forcing it to have 30 bins. So since our data set here is age, and age, the observed values of age, let's actually look at what that looks like. So just to give myself a quick view of this, down here in the console, I'm going to actually just use my table function to help me summarize age. So I'm going to type the name of my data set, which is student_data. Use the $sign to call the age variable. So here we can see we had 82 students that were 15, one student that was 22, but overall we've got 8 values for age. But by default, our, or ggplot, is going to try to place that into 30 bins. That's why you actually have all of this blank space here in this histogram, because for this particular data set, even though it's quantitative, it only takes 8 values. It doesn't make sense to make a histogram that has 30 bins, because what you're going to end up with is some empty bins here. You know, we don't have any students that are 15.75 as their age, so it's not that these bars are separated like a bar plot. It really is that ggplot is trying to put empty bins in between, which again just doesn't make sense for this particular data we're looking at. What would make more sense would be for us to either specify the number of bins that we want, so we could say we want 8 bins, or we could specify the bin width or the bin size. So what we're going to look at next is a histogram with a couple options. So let's first just talk about the structure of this code here. Notice that I have 4 different lines. So let's talk about what those 4 different lines are doing first. The first line is the ggplot line. Remember, this is creating your base or your empty plot. And inside of the arguments for the ggplot function, I've included 2. I've got the data set, which is always going to go in there. And then here I've also included the mapping piece inside of the ggplot. And remember, this is an option that we can choose to do. We can either put that mapping information into the ggplot in the top portion, or we can put it in the geom functions down below. Either way will produce the same plot. So that's our first line of code. That's the ggplot, creates the blank plot, lets R know what data set we're going to use. My next line here is the geom histogram. So remember, the geom line is going to build that next layer that has the actual histogram. And so this is where I'm going to put the options for the histogram that I would like to see. So here I'm going to tell ggplot I want a bin width of 2. So in other words, I want the 15 and 16-year-olds to go together, 17, 18, 19, 20, and 20, 21. I'm going to say color equals blue and fill equals red. So there are 2 different options here for color. The color argument is actually going to do the outline of the bars, and then the fill is going to fill in the bars. And then my last 2 lines here, we've seen these before in the previous video. We have the GG title, which gives me the title of the histogram, and XLab, which is going to label the x-axis. Well, notice currently the x-axis is labeled as age. Here I'm just changing it over to be capital H. So let's run this. And notice my histogram now looks a lot better. It looks more reasonable for the data set that I'm looking at. So looking here, and oh, I apologize, I misspoke a little bit earlier when I spoke about the bins. They are with 2 here. Notice we're going from our 15 to 17-year-olds are in the first one, and that will not include 17. So really that's going to be the 15 and 16-year-olds. And then we've got 17 to 19, which will really include the 18 to 19-year-olds. And again, this is because of, you know, if we talk about the upper and lower limits of a histogram, you know, if you have ones that are on the edge, they generally populate into the next bar, and then so on. But notice this histogram looks a lot better than what we had before. Let's say instead of bin width of 2, I just wanted each age group by itself. We could run this, and notice here we have a bar for each of the ages. All right, so that's a little bit more about histograms. Let's next look at bar plots. So bar plots are very similar to histograms, except they're used for categorical data instead of quantitative, and we've looked at bar plots some before. So let's just start out with a basic bar plot where we're going to look at father's job. So again, my first line of code here is the ggplot, creates that blank base layer, and so I'm just telling it the data set that I would like to use. And then I want to use the geom bar layer, and here the value that I'm looking at is fjob. That's the variable that goes along with father's job. Right, so here is that bar plot. Notice here we do have the blank space in between the bars. Those are not representing empty bars. Those are that space that you should have with a bar plot. So remember, in a histogram, bars should touch, and a bar plot, bars should have a space in between them. Now notice here on the left-hand side, we have the counts. Often when we're creating bar charts or histograms for that matter, we don't actually want the counts on the x-axis. Really what we want is the relative frequencies or the proportions so that we can see relative to one another what percentage occurred in what category. So to change that, what we do is we still use the base ggplot and we call the data set, but here inside of the mapping we're going to do something just a little bit different. So notice I've got my geom bar, and here I've still got x is equal to f job, but now what I'm going to do is add in this little piece here. So what we're doing is we're telling R that everybody comes from a single group, and for the y-axis we're going to use the stat function. We're going to talk about stat functions just a little bit more in a little bit, and prop. So let's run this and see what happens. Notice what it does is it now puts the proportions on the y-axis instead of the counts. And so looking here, I can see about 50% of the father's jobs falls into the other. Now, of course, we could add on to this just like we did with the histogram and put a title on and an x-axis. But that is how you can change in a geom bar, instead of having the counts, to have the proportions on the y-axis. And again, that's by adding in this little piece of code right here, and this will not change. This will stay, from data set to data set, this little piece will stay the same. So let's talk a little bit more about the stat function. Now, one thing that, if you recall, when we worked with the base functions in R, in order to make the bar plot, what we had to do was first create a table of all of the categories, and we had to include in those categories the counts. And then we fed the table in as the data set into the barplot function, and that's what created our bar plot. Notice we haven't had to do that in ggplot. ggplot automatically does that for us, and part of it is these embedded what are called stat functions into ggplot. So for example, we're going to look at the stat count function first and see what that does. So I'm just going to run this. And if you'll notice, when I run the stat count function, it actually produces the exact same bar plot that we saw when we used geom bar. That is because embedded in geom bar, if you kind of looked under the hood and saw what that function was doing, you would see that it's actually using the stat count function. And the stat count function is essentially making a table with all the counts for this categorical variable, and then it's creating a bar plot of them. A lot of the ggplot functions are going to have these stat count things going on under the hood. The same thing is happening with the geom histogram. And so ggplot is kind of taking care of that portion for you so that you don't have to do that. There are other stat functions that we could use. So this one was just looking at the count of those categorical variables. Let's look at some other options. Another one that we have here is stat summary. So let's just run this and see what it produces. So here's the plot that this stat summary produces. So looking at the different pieces of stat summary. First, notice in the mapping, I'm going to feed it two different variables. In the x-axis, I'm going to feed it father's job, and we can see that here along the x-axis. Along the y-axis, we have number of absences. And then we're going to have two different, or probably three different functions. We've got the max, the min, and the median. So what this is doing is for each different type of father's job, it is marking the minimum, the maximum, and the median in terms of absences. So we can see for those that work at home, we can see that the median, denoted by this dot, is approximately, I'm going to say 3 or 4. The minimum is at 0. And then the maximum here is about 15. And notice it would make sense for all 5 of these categories to have the same number of minimum of absences, because of course the minimum number of days you can miss is 0. So you'll notice the minimum for each of these is 0, which makes sense. Interestingly, the median for all of them is very close. There's a little bit of variability, but not much. But the maximum number varies drastically across the different services, or probably across the different jobs. With those working in the services sector, the maximum is much higher than those at home. Now, one thing to note that some of the information that is lost here is the number of observations in each of these categories, and that could be playing a role as well. So remember, whenever we plot data, we want to be careful because there is always the potential for some information to get lost within a plot. And if hopefully you're following along with that online textbook R for data science, I highly recommend reading through the recommended readings for this section, because the recommended readings are going to talk more about that stat function, which stands for statistical transformations, and what's going on behind. There's some nice images in there that kind of show that relationship and what's happening when ggplot is going to create these bar plots. Let's look just a little bit more at some bar plot options, and these are going to be pretty similar to when we just looked at the histogram. So we're going to start out again by making that bar plot of father's job. Notice here this is the same as before. Here I've used the stat count. Again, I could have used the the geom bar that I used up here to get the same plot. Here I'm setting color equal to blue. Remember that color is going to be the outline of the bars. So you can see when I ran this, the bars all have the blue outline. Whereas the fill option is going to fill the bars with blue color. So we have that here. Here's another option. We could create a bar plot of father's job with colors corresponding to failures, where failures is numeric. N if 1 is numeric, and if n is greater than or equal to 1, strictly less than 3, or else it's going to be 4. So what this means when we talk about the number of failures a student has, if they failed once, the value is going to be 1. If they fail 2, it's going to be 2. If they fail 3, it's going to be 3. If they fail 4 or more, it's just going to be kept at 4. So the first thing we're going to do is we're going to change student failures over to a factor. And so what we're doing in this line of code, remember that anything before the $sign is the data set, anything after is the variable. Well, failures.factor didn't previously exist in the data set, so by calling student data $sign failures.factor and setting it equal to something, we're actually adding this variable onto our data set. So notice if I go up to student data, now that I've ran that, go to the very end, you'll see there is this new failures.factor. The reason that we needed to convert this over to a factor, and notice the conversion is done by using the as.factor function applied to the failures variable from the student data set, is because ggplot works with factors. So always keep that in the back of your mind. ggplot wants to work with factors. So what we're doing here is we've got ggplot, we've got data, again equal to the student data set. We're going to use that stat count. I could have used the geom bar function as well. In my mapping, here I'm still saying that x is equal to father's job. That's the data set that I want. But notice instead of fill being equal to blue, I'm setting fill equal to that factor that I just created. So running this, we get a really nice stacked bar plot. So this is a way to do a nice bivariate comparison. So here, what we're doing is we are comparing two different variables. We're comparing father's job, and we're comparing that to the failures factor, which is the number of failures that a student would have. All right. Oh, and I just realized there's actually an error up here. If we talk about number of failures, the lowest number of failures a student could have could be 0. So let me fix this really quick. So just to get a look at failures, let's actually look at what that looks like. So we've got student underscore data $sign failures. So notice here the maximum number of failures isn't 4, it's actually 3. So here, and really the error is just in the comment, the code is fine. It's going to be n if n is 0 to 3 and else 4. And actually we didn't have any 4s here, so that's kind of unnecessary. But that's why we see a 0 here where I had a 1 before. So again, just an error in the comment, not the actual code. All right, so again, going back to this bar plot and what we're looking at. So again, we're making this bivariate comparison between the type of job that a father has as well as the number of failures a student may have had. So within each of the bars, we can actually look at the count of how many within each type of job, how many failures we had. So for example, if we look here in the other category for father's job, if we start down here with 3 failures, we can see that we had approximately, I would say, around 10 students who failed, and then we would look at the count on top of that and so on. Now, we do want to be careful when it comes to working with stacked bar plots in ggplot, because there's different ways that those positions can be made as far as how the bars are stacked. Are they stacked directly on top of one another? Are they stacked right in front of each other? You know, how is that actually done? So we're going to look at next what's called position adjustment to talk about how those relationships are actually constructed here in these plots. Alright, so I've got a little note here. It says the position argument will alter the position of the sections within the bars. So what we're going to do here is we're going to, instead of stack count, I'm going to use G on bar. Again, you can flip between these. And we're going to look at some different position arguments and see what changes. Now for each of these, what I did for the mapping, I'm still having the mapping where we have X is equal to father's job, and I'm still going to set color equal to that factor, which is the number of failures. But notice that I've put them here into the ggplot, and remember, we can put the mapping up there, that's not a problem. And the reason I want to do that is because down here in the G on bar, I want you to see what I change, so we can see what changing the position changes. Alright, so here I'm going to set position equal to identity. Alright, so here by setting position equal to identity, and I've set fill equal to NA, in other words, we don't have any fill, just to help us kind of see what is going on here. The position equals to identity places each object exactly where it falls in context of the graph. Using this one is not very useful for bars because essentially what it's doing is it is overlapping the bars. So it's not actually stacking them, it's overlapping them. So to see that overlapping, we either need to make the bars slightly transparent, or we can make them completely transparent by setting the fill equal to NA, and that's why I've done that here. So what we're saying is if we looked here, what is actually happening? Notice here, you can kind of see it here with the blue and the purple here under the other position. You can almost think of this as really being three-dimensional. The red bar is all the way in the back, and then the green's right in front of it, and the blue's right in front of that, and the purple is right in front of the blue. And so for this reason, this can be a little deceiving. And to see this, let me flip back to the one we had before. Notice when we actually had these in the stacked bar plot, the total height for other was somewhere not quite 250, probably like 230. But when we go to this one, notice the height drops to around 200. And so what is happening is here the bars are stacked on top of one another, so you have that height, whereas in this plot they're stacked in front of one another. So not very useful, but this identity can be useful if you work for two-dimensional like points or other things like that, where this is actually the default to place things on top of one another. Alright, let's look at another option. So here we have position equals fill. So again, here I've put the mapping down the G on bar, but it could have been put up top just like the one I have above. And the real difference here is we have position equal to fill. So we can run this one. Alright, so notice with fill, it works similar to stacking, but what it does is it makes each set of stack bars the same height. This actually makes it easier to compare proportions across groups. So this is a little bit different than when we looked at the bar plot before and we did the proportions. When we looked at the bar plot before and we did proportions, it did the proportion for the whole data set, whereas here we're looking at the proportions within groups. So for example, if we compare for father's job those that work at home and those that work in the health industry, we can see pretty quickly comparing these that there's a big difference in terms of the 2 and 3% of failures. Here at the at-home, it's very close to 0% had 2 failures. Here in the health, it's very close to 3% had 3 failures. But if we look at the comparison between the 0 failures between them, they're slightly, actually less failures, because remember we're talking about 0 failures here in the health. Also, looking across them, the group that has the highest proportion of no failures, not surprisingly, is the teacher's group, and the teacher group has 0 students with 3 failures as well. So again, each of these bars, the proportions for them are not the proportions overall, the proportions are within the groups. And then one other one we could look at here is the position equals to dodge. And position equals to dodge places overlying objects directly beside one another. And so this makes it easier to compare the individual values. So if we go back to our first one we looked at, which wasn't that informative, this one is placing the bars in front of one another, which visually makes it very hard to see that comparison, whereas dodge is placing them beside each other. So this one has the benefit of, again, we can compare each of the groups to one another. We also can see, in terms of, if we look at the other group here, it had the most observations, whereas this one allows us to compare proportions across groups, but not the number of observations per group that this one does. So each of them has, different benefits when we go to make those comparisons, and I just want you to be aware, there's different ways that you can construct these, and these bivariate comparisons between 2 categorical variables. All right, our very last thing that I wanted to show you were the cheat sheets. So there's not actually a line of code here. The people who created RStudio have made these really nice cheat sheets to help you with just different packages within RStudio, and so I wanted to show you these. If you go to Help and you click on Cheat Sheets here, or hover over it, you'll notice that there are a bunch of different cheat sheets that appear, and there's actually a lot more than this. But we've been working with ggplot, so if you click on the data visualization with ggplot, that is actually going to take you to a website, which the way that I'm sharing my screen right now, I'm not sure that you're going to be able to see. Let me see if I can drag it over here. Sorry, for some reason it didn't pop up on mine. Drag this over. So it should have opened a page that looks something like this. And so what you will see here is it's a front and back size cheat sheet that just has a lot of the different things that we've talked about and even more. So these are kind of nice to print off and keep handy. So you'll notice here when we've talked about several of the different geomes, but there's even more of them here. And it's nice because they've got them broken down into, here's the 1 variable ones, here's 2 variable, notice it got broken down to 2 continuous, continuous bivariate, discrete and continuous, discrete and discrete, maps. There's all different kinds of geoms here, and again, they're just nice little cheat sheets, and these cheat sheets are available for all different kinds of things. So you'll notice if you go back to the cheat sheets, there's also, let's see if it's on here. Okay, they don't have it on here, but there are, oh no, here it is. There's the R Markdown cheat sheet, and so the R Markdown cheat sheet, that's a cheat sheet that goes along with the notebooks that you've been building in lab. Later on, we'll talk about dplyr, so there's one here for dplyr. We won't get to Shiny packages in this course, but if you're interested in Shiny, there's a really nice cheat sheet on that. So I just want to make you aware of those cheat sheets. If you can, they're great to kind of print off and have next to you, or just to have that page bookmarked so you can always flip over to that, and that'll just kind of help with some of the basic syntax for these things. All right, so as always, if you have any questions about this, please let me know, and I will see you this week.